everyone. Unfortunately, I don't have any videos for you. However, I can relieve you from looking at how many tabs have you got open, Jen? There's one. Oh, I mean, I'm impressed that you can work like that, but it was stressing me slightly when I looked at it. So here's one tab. Okay, and I'm also going to talk about test doubles. I'm just going to move this. Yeah, so that's my name, Rabea Gleissner. I'm a software developer, and I work for a company called Eighth Light. And Eighth Light is a consulting company. We write code for our clients. We do anything from mobile apps, building APIs, web apps, payment systems. So we have quite a broad range of projects, which is fun. And I consider myself a polyglot developer, so I've worked with different languages. Currently work on a Ruby project with a React front end. I've worked on a PHP project before. I know Java. So I've done a few different projects. All my code examples tonight will be in JavaScript, of course. But I think the topic in general, test driving your code or unit testing and using test doubles is probably transferable to any language. So yeah, can be used in any language. When I first learned how to write unit tests and how to test drive my code, it seemed like some tests were pretty straightforward. Some functions, the input, the output. Okay, you can test it. But some seemed really, really hard to test. So just an example of, here's one which is pretty straightforward. So we all, or most of you, I assume, know FizzBuzz. So it's a program which takes in a number, and depending on if this number is divisible by 3 or by 5, it returns fizz, buzz, or the actual number. And this is easy to test, right? Because you put in a number, let's say 3, fizz will come out. Cool, so you can assert on that. The test will look something like this, so you can easily instantiate a new FizzBuzz object. It doesn't even have any dependencies. You say, okay, FizzBuzz, generate me the 2, and the 2 will come out. So that's all cool. And why this is so easy is because that function that you just saw is a pure function. There are no unexpected side effects, so you know exactly what the output will be depending on the input. If you had some function that, for example, would have a random number generator, and you had to add in, I don't know, the number that you put in, add it to some random thing, then it would be really a bit harder to test because it's not pure anymore. If you had a function that did a database call, or let's say it called like the weather API, and it would return sun today and rain tomorrow, then it's really hard to test because the function isn't pure anymore. And also, this little program didn't have a lot of dependencies, so it's very easy to instantiate that and test it. But let's look at this. So this is I actually prepared a little rock, paper, scissors game for all of you tonight. We'll see that in a minute. Here's my first example from this code. So the rock, paper, scissors class has 3 dependencies: the UI, the human player, and the computer player. And let's say we wanted to test the run method. We would have to instantiate this with 3 dependencies, which is kind of okay. But when we look at this, so this is the code when we want to play the game and actually instantiate a new rock, paper, scissors, we see that the UI is also dependent on console input and console output. So it's getting, we've already got 5 dependencies here, so it's getting a bit of a hassle. And obviously in bigger, like real, production code, you can get loads of dependencies and have like a whole lot of trouble in your tests. Here is an example of a function that gets some data back. So let's say we wanted to test that the fetch call is made with the correct URL. So the URL is constructed here with, that is a constant somewhere up in the class, and this is another function that gets the filter criteria that need to be appended. So every time you run that test, it makes an actual fetch call, right, which is a bit of an issue. So because let's say you need to pay for each time you make a call to the API, or I don't know, if you run your tests all the time, if you're test driving your code, which obviously we're all doing, then yeah, you make loads of requests to this API, and yeah, it might not expect that. So But there is a solution to this, Testables. So, what is a Testable? It's a class usually, or a function that stands in for your production code in your tests. So you can just swap one of these dependencies that you have, swap it out with something else that is a lot simpler, that can return certain things that you need for a specific test. As long as it conforms to the interface of the collaborators, then it's fine. So as long as it has the right functions on it, and yeah, then you can use it. And I already hinted a little bit at why we would use it, with these examples that I've showed earlier. So we could reduce the amount of dependencies. We can make impure functions pure, so they're easier to test. It also makes our tests less fragile if there are fewer dependencies. And we can also force our code to execute certain branches. So, I don't know, if we have a certain if-else statement and we need to make sure that one particular branch of that is tested, we can force it to run that branch through using test doubles. So let's look at this one again. That's basically the same thing I showed just now. If we want to try to write a test with this without using test doubles, I would have to get this console input, which is actually a library, an npm package to get a console prompt. So we have to get that dependency. We need the console, where we can do console.log to print something to the console. So then we have the UI, and then we can put the UI in here, and then the human player also needs the UI, and finally, we've got all that done. We say game.run, but how do we even, so we don't even know how to assert on that, because it's not really getting something back. So that run, I'll show you that in a minute, but the run function doesn't really return anything. So it's kind of hard to assert stuff on it. If we use test doubles, we can use a UI dummy in this case. And I'll get into that in a minute, what exactly that is. So a lot fewer dependencies. We just instantiate a UI dummy, and we also use fake players. Because the computer player and the human player both have just one method, which is called make move. It's exactly the same method. We can just use a fake player that has the method make move, and then we just put that same thing in there twice, and then it all works great. Before I show you some more of rock, paper, scissors, these are the types of test doubles that I wanted to go into today and show you what the differences are and how they can help us write better tests. And I think it is important to differentiate. So a lot of the time, or I hear people say, oh, we'll just mock that out, or yeah, we'll just use a mock or whatever. Or, and then names get kind of mixed up, which one's which. And I think it's really important to name them correctly, so when someone else reads your code, or even yourself, future me reads the code in like a month's time, that I still remember what this test double was and why I was using it. So yeah, I think we should make our code as expressive as possible and as easy to understand as possible for anyone. So that helps, like the correct naming helps. But let's get into the rock, paper, scissors. Actually, I think I have to stop mirroring I have to start mirroring this, it's easier. Cool. So the way it works, you can enter a move, and then the computer will make a random move, and then it tells you who won. Jen, which move do you want? Rock, paper, or scissors? Rock. Cool. Oh, unfortunately, we lost, but we can play again. So you play again, yes. Let's say paper. Yay! Paper again. Okay, and so on. And I tried to make it probably a bit more, well, I created a few more classes than may be necessary to have such a simple game, but I thought I just wanted to illustrate how to use the test doubles with this. So we start here. So that might look familiar to you. This is where we instantiate the game. And so the rock, paper, scissors class is instantiated with the UI, the human player, and the computer player. And this is the run method, which is we want to test at some stage, and playing one round means we get a move for the human and a computer move. Both of those come from the player. So for example, if we look at human player, that has the make move method, and the computer player also has the same one, except, the implementation is different, but they have the same interface, which is handy because then we can just use a fake player, for example, in our tests. We also have the UI class. Let me close this. Which does all the talking, basically, all the talking to the user. It greets us, and it asks us to enter a move, and it announces the winner, and all the things that you saw earlier. I think that's enough of that for now. We can carry on with this. So the dummy is the first testable that I wanted to demonstrate. And the dummy implements any function. It basically just satisfies the interface. It has all the functions that your code will call, but there's nothing in it. It's just an empty body, unless it has to return something. So if you use a typed language, for example, and you specify the return type, then you might have to return whatever the return, if it's string or undefined or something might sometimes work. But so it's very simple. It's basically just empty functions like that. So I just showed you the UI with all these things that it was printing, and it was trying to get input from the user. But in the test, we could just have that. So if I look at this test here, which tests this is it, play the game. So this plays one game, and we are just using this dummy here. And the function that is called is game.run. And you can see that the UI is called all the time, but we don't really need it for this test. Here UI.announce computer move, UI do this and that. But it's not really necessary, because what we want to assert is that the fake human, that the human player was asked to make a move. So we don't need the UI. So we don't even need to bother with all these dependencies, the console and the prompt and all that. We just use the dummy. And as long as the functions are there to call, they don't need to do anything, then the test works. The Stub is a slightly more advanced version of a dummy. It has an implementation, but it's very simple. It will return one thing, maybe. It wouldn't have any business logic to it. I also have an example here. Maybe I'll just show you this in the code. Yeah, the human player. I think if you wanted to test that this method would return a move, because that's what we need from this method, it needs to return rock, paper, or scissors for the rest of the code to work with it. So we could test, and because it uses the UI again to ask for a move, and in the test we can't really, have a prompt to the console and ask wait for someone to enter something, because it needs to run automatically. So instead of having the real UI, we use the Stub, which is down here. And if ask for move is called, it will just return rock. So then we can assert that when we call that method, rock is returned. And when I first learned about this, I thought, isn't this kind of cheating? Isn't this really, how can I just use something different? But as long as all classes are tested, they don't have to be tested through other classes to work. As long as they're all tested individually, then that's fine. And then we can use test doubles like that. So it's not cheating. A spy is a class that can tell you what some other code has done to it. So you can say, it can give you feedback that a method was called, or how many times it was called, or that certain parameters were passed into the method, or that the right number of parameters were passed into it or something. So that's really useful to assert things on. I'm going to show you this. So we want to test that this method greets the user. And when we actually run that game, we are passing in console as output. So we can say console.log. So the constructor takes input and output, and for the output I pass in just console. And then here it would know that output is actually console, so console.log would print out, welcome to rock, paper, scissors. But in the test, I'm passing in the output spy. So where the UI is instantiated here, and we have the output spy here. And this spy has like a completely different, the internals are completely different, well, almost completely different from actual console. The only thing that it needs is that it has to have the log method, so we can call .log on it. And, but what it really does is that it sets message to the message that you pass in here. And then I added this function printed message, and I can use that to return what the actual message was that was printed. So I don't need to log anything to the real console. I can just record it in this spy. And then I can assert that the output spy.printed message is the correct one that I need. There's also a fake, which is usually a lot bigger than these other three that I just showed. So a fake could be, for example, an in-memory database. If you, I don't know, if you have some code that calls a real database for your test, you could implement like an in-memory database that is used there instead. Or actually, Sarah and I just worked on a project where we had to make an API call to a service that wasn't quite finished yet. So we wrote our own fake service, like a very simplified version of what it actually does, just that we can make that call and get some data back and do something with that data that we were, needed to do. So it's almost like a little system in itself. And we've even gone so far as to write unit tests for a fake if it was a kind of a complex fake. So it can even, I guess, it can, get very testy. But yes. So, but yet, so it's not suitable for production code. It's just for your tests, but it can stand in for real services or databases or so on. I also have a fake example in my rock, paper, scissors game, even though it's very small, which is a fake player. Maybe I can. Yes. So in this test, where we want to check that one game was played, we instantiate a fake player with paper, because that's something that it needs to return at some stage. It needs to say the move that I want to make is paper. And an array of n or y, because n for no, I don't want to play again, and y for yes, I want to play again. If you want to play two games, that becomes more clear why we need this array here, because first you want to say, yes, I want to play again, and then, no, I don't want to play again. And the fake player, so it has this make move method. So it just returns the move that it was instantiated with, so paper in this case. So it's a lot easier implementation, and we don't need to rely on the UI and giving information to the console and so on. I've also hidden a small spy in here. As you can see, it counts. So I have a kind of a count field, I guess, which starts off being 0. But every time this method is called, then it is incremented by 1, and then we can assert that the method was called, in this case, once, and in this case, twice. There's also Testable, which I think is kind of the umbrella term for all of these that I just showed. So in reality, I probably should have called this one double because it's a spy and a fake, but I wanted to show a fake example, so there it is. Yes, so a little side note that all of these are just passing in this stub here and this fake here. It's not so easy when you have a typed language. Do we have any fans of TypeScript, for example, in the room? Ah. Or any people who have used TypeScript and are not fans in the room? Ah, okay, cool. Anyway, so I have prepared a little TypeScript example for us. TS, yeah. This one. Yes, very good student there. Well done, A star. So, correct. We will use interface. Let me turn that around. So this is kind of a simplified version of what I showed before, but I just wanted to say, let's imagine we want to instantiate a new rock, paper, scissors class, which has a human player and a computer player. And let's imagine we wouldn't use interface and just call this human player and computer player, and in here the same. Then all we could ever, oh god, this white space, I have to get rid of that. Okay. Then all we could ever pass into this constructor would be these exact classes, the human player and the computer player. So we would have a bit of a problem if we wanted to use test doubles. But in this case, this is how I had prepared it actually. I created the player interface, which has that one method, make move, and it needs to return a string. And our fake human implements this interface here. And our human player also implements the interface, and the computer player also implements the interface. So as long as all these classes that we want to pass in conform to the interface, then it's fine, and we can use test doubles. And I think it's probably even safer to use test doubles because you have, if you specify an interface with make move, it has to have that method. That means, if you have this interface and every class that implements this has to have this method. So at least you can be sure in your tests that, at least the method will be there. So it's maybe a bit safer even using these test doubles. I also wanted to kind of course, give a nod, I guess, to the test frameworks that have all this stuff inbuilt. I mean, or most of this stuff. But I just thought it would be fun, for this talk, just look at the different examples and different types of test doubles that there are. But for example, I was using Jasmine with these examples. And you can, there are Jasmine spies, and you can say that these spies should return some specific thing. So I know, like at work, when I write code, I hardly ever roll my own test doubles. I just use the ones that are there. But yeah, for this talk, I thought I'll do that. And that's all I've got. Thank you for listening.